Good morning, students. Last session we are done with photoelectric effect. What is photoelectric effect? And we have done why electromagnetic wave theory was not able to explain the photoelectric effect. And this effect can be explained on the basis of Max Planck's quantum theory. So first, let us do what is Max Planck's quantum theory. According to quantum theory, energy is absorbed or emitted by any body, not continuously, but discontinuously in form of small packets of energy. Called quanta. These packets of energy are called as quanta. Quanta is the plural of the word quantum. Single packet of energy is called quantum and many packets of energy are called as quanta. The quanta is just the plural of quantum. So what it says, कि energy, if any body is there and it is giving out energy or it is absorbing energy, it will not be done continuously, but in the form of small packets of energy. And these small packets of energy are called as quanta. And in case of light, each quanta is called photon. We call each quanta as photon in the case of light. So he said that light is not wave, it is not continuous. But when it is being absorbed or emitted, it is absorbed, taken in the form of small packets of energy. And these packets of energy as quanta, and light ke case mein they are called as photons. Secondly, he said energy of each quantum is directly proportional to the frequency. So he first time related energy to frequency, because we know that according to electromagnetic wave theory, energy depends upon intensity. But here it is saying that energy is directly proportional to frequency nu. And when we remove the proportionality sign, we get the constant h. H is called as the Planck's constant, having the value this is the value for the Planck's constant. So I can say that energy is emitted or absorbed in integral multiples of h nu. This is the energy of one packet, one photon, one quantum. So if I can say that from any source energy is emitted, so I can say the amount of energy emitted is 10 quanta. The energy of 10 quanta will be 10 into h nu. So energy is emitted or absorbed in integral multiples of h nu. Energy is emitted or absorbed in integral multiples of h nu. That means E is equal to NH nu, where N can be 1, 2, 3 and so on. It cannot be in decimals. So a particular object can absorb or emit 5 quanta energy, 6 quanta, 7 quanta, 8 quanta, not 8.2, 8.5, 8.6, no, not in fractions. So they will emit or absorb packets of energy. So these are the main points of the quantum theory given by Max Planck. Now we will see how Max Planck theory was able to explain the photoelectric effect. We have seen that in the photoelectric effect, to eject an electron, a particular frequency of light is required, a minimum frequency of light, which is called as the threshold frequency. So in photoelectric effect, minimum frequency of light which is required to eject the electron from surface of certain metals is called threshold frequency. We have already done it. Is called threshold frequency, represented by mu naught. Represented by mu naught. And the energy corresponding to this frequency mu naught, according to Max Planck quantum theory, we know that the energy can be calculated. E is equal to h nu. So I can say E naught is equal to h mu naught. The energy corresponding to a light of frequency mu naught is represented by E naught, or it can be represented by W naught. W naught is called as the photoelectric work function. That means minimum energy which is required to eject the electron is called photoelectric work function, W naught or E naught. I can represent by any one of them. So this is the minimum frequency, and the energy associated with the light of minimum frequency is E naught, or we can call it photoelectric work function, W naught. Now, if a light of frequency mu strikes the metal surface, right? Metal surface, a light of frequency mu, and mu is greater than mu naught. You know, if the frequency is greater than the threshold frequency, then the electron will be ejected. So the light which strikes this metal surface has a frequency greater than mu naught, and the energy associated with it. What is the energy associated with it? E is equal to h nu. This is according to Planck's quantum theory. So this is the energy associated, and I know that if mu is greater than mu naught, E is greater than W naught. The minimum energy I require is E naught, but I have given a light of energy E, right? So where the extra energy which I am giving it to the metal surface, that extra energy is converted into the kinetic energy of the electron. The extra energy which is given by radiation is converted into kinetic energy, is converted to kinetic energy. So just see what we can do. We know that E naught is equal to this, or W naught is equal to h mu naught. These are equation 1. This is equation 2. We know that E is greater than E naught or W naught, the work function. So what is the difference between E and E naught? It is equal to kinetic energy. I'm just giving you an example. This is the potassium metal. You know potassium metal has the nucleus, and its configuration is 2, 8, 8, 1. You know potassium has the atomic number 19, so the configuration is 2881. Suppose to remove this electron, you require energy, because this electron is tightly held by the positively charged nucleus, and to remove this electron from it, you have to give energy. So suppose I have to give the minimum energy which is required to remove this electron is 50 kilojoules. Suppose, it is not that, but I am just supposing this value. I have to remove this electron, so I have to give minimum 50 kilojoules of energy. So E naught is 50 kilojoules. But instead of 50 kilojoules, if I give a light of energy 70 kilojoules, so 50 is enough to remove the electron, and rest extra 20 kilojoules will be converted into the kinetic energy of the electron. That's why I've written E minus E naught is equal to kinetic energy. That means 70 I have given, 50 it requires, the 20 extra which is there is converted into kinetic energy of the electron. Now E minus E naught, I can put the value of kinetic energy as half mv square. We know that kinetic energy is half mv square. E, I know E is h nu and E naught is h nu naught is equal to half mv square. We are just modifying the equation. H I can take common, nu minus nu naught is equal to half mv square. We can write our formula. Further, we know one thing more. We know that frequency is related to wavelength. Nu is equal to C upon lambda. I can substitute this value. H C upon lambda minus C upon lambda naught. Because wavelength C is velocity. Velocity will always remain same. It cannot change. So I can write like this, half mv square. So I can take hc common. 1 upon lambda minus 1 upon lambda naught is equal to half mv square. So lambda naught, mu naught is the minimum frequency required to eject an electron, and lambda naught is the maximum wavelength required to eject the electron. This wavelength is required to eject the electron. So this much is at least required. So that is lambda naught. So this photoelectric effect could be explained on the basis of Max Planck's quantum theory. And so now we know that the number of electrons ejected, although they depend upon the intensity of light, but the energy depends upon frequency and not intensity. So this photoelectric effect showed that energy was depending upon frequency, and Max Planck proved, yes, energy depends upon frequency if we consider that electromagnetic radiations are made up of small packets of energy. That means they have got particle nature and not wave nature. Thank you.